weight of the water.
Yeah, of course. Means that if we are merging a X volume block inside a water, then the same amount of X volume water will be displaced, right?
Yes.
Okay, so now we have the. Did you solve the problems?
Which one, sir?
Did you get any problems? I think 3, 4 problems yesterday, home assignment.
Yeah, but I didn't send it till now, sir. I
Okay,
didn't get time to do it.
okay, okay. So today we will start with the application of Archimedes principle. Okay, so there are few applications. It's too late, right?
What's up?
Sometime. I was waiting for you at 8 and 8.5.
Yeah, because you know, we didn't know that we were gonna have physics class. We were thinking chemistry.
Okay. So
I was
the
thinking
application
swimming
of,
class.
sorry.
You called me at the time when I was having swimming class. That's why we couldn't go and log in.
Uh, but I got that 8:30 time from the admin.
Yeah, but they didn't tell us. That's why we
Uh,
didn't.
then he told me that at 9:30. I said, oh, no issue.
Yeah. Okay.
So now we studied the Archimedes principle. We know about the density of different liquids. Uh, now it's time to see what is the use of Archimedes principle. Archimedes principle is used to determine the relative density of substance. What is relative density of substance? We will see in a moment. Okay.
Okay.
The hydrometers used to determine the density of a liquid are based on the Archimedes principle. Have you seen the hydrometer?
No, but I guess it's a meter to see the temperature of water.
No, it's not the temperature of water, but to see the
Density, to see the
density of the
density.
water. Okay, so hydrometer is made up of, there are at the bottom, this is weight. It might be filled with some metals. Okay.
Hmm.
And in gas tube, there are another type of liquid. Okay.
Okay.
With some scaling, and we dip it into the water. Okay. So this weight will be displaced by the liquid, this water liquid, or whatever it is outside. This will apply the buoyancy force. And that buoyancy force depends on the density, that is directly proportional to the density we see last time. So according to the density is what now, it's the thickness, thick water. If water has less density, and we know that mercury has more density, so mercury is more thicker than water, like.
Yeah.
So if it will give you the particular reading, if it is 1, suppose it is the density of water. If it is 0.9, it may be the density of ice, because density of ice is less than water. So using these scales, okay, this scale, we can determine how the density of this liquid is. Okay.
Okay. Okay.
So this is one of the use of hydrometer. I asked one question to you in the assignment, why it is easier to swim in the Dead Sea with respect to the fresh water. We know now people float on the Dead Sea. But why this happens? The answer will be, this is your assignment question.
Why is swimming in seawater easier than fresh water?
Tell me, what could be the reason?
Mm, because sea seawater has s- seawater has a higher density than freshwater.
Yeah. Similarly, the lactometer used to determine the purity of milk are based on the Archimedes principle. So milk having some specific densities, yes, right?
Hmm.
Milk have some specific densities. If
Yeah.
if we use the lactometer, if the same, if we have added water to it, maybe the actual densities may vary after adding water. Okay, so if we are not matching the same reading on this scale, this may be then milk will be some mixing or something, right?
Yeah.
So lactometer is the one machine based on this principle used to measure the purity of milk. Archimedes
Okay.
principle is used to design the ship and submarines. Okay,
Okay.
so you write it down.
So finished.
What about this graph? Hydrometer picture?
I didn't draw it, but I can take on screenshot of it, sir.
Okay. Not are you writing those things in the notebook?
Yeah, I wrote that, but I didn't draw the figure.
No, so draw in the notebook only. Don't do half thing in the notebook and half thing in the gazette. Got the
Okay.
idea?
Yeah, because I wrote the hydrometer, what it's used for, but
So
So finished.
Okay, now move further. Again, we have the same question. I think we already discussed this. Why an object sink? Now it's in term of Archimedes principle. Okay. So,
Okay.
so why of object float or sink in a liquid? So this is the liquid. We already knows. We already discussed this. Okay.
Yeah.
It may be the in the order of the book. Okay. So we have an object. Say it is on the surface of mass m. So how many force actually acting on it? One always act toward the gravity, that is mg, right?
Yeah.
So there will be one force another, because we know from Newton's third law, there is always equal and opposite reaction.
So there's one upward force pushing it up.
So there will be an upward force. We say it buoyancy force, right?
Yeah.
So there is three couple of situation that either B will be equal to mg, right? Second situation is B will be greater than mg. Third situation will be B may be less than mg, right?
Yeah.
So what are all these three situations? In which situation the object will float or sink?
It will be for which one? For why objects float or why objects sink?
Yeah, in out of these three relations, in which situation you think that object will float or sink? Or what about this scenario in this situation?
Here will be equal, so the object will float.
Okay. What about the other situation?
Second one,
Yeah.
it will sink.
B is greater than mg.
No, it will float. It will float.
What about the third one?
That will sink. It will sink.
Okay. So here it says that weight of the object acting downward, which tend to pull the object downward, that is gravity. This is responsible for the object to float or sink. And another is the buoyant force acting upward, which tend to push the object upward. So these are two forces responsible for buoyancy. Okay, clear? And all these situations are clear. Equation 1, 2, 3, right?
Yeah.
You make it, write it down. And you, if you wish, you can just write some short notes against each of the equation.
Okay. So finished.
Okay. These are the three situations we already discussed. If buoyant force exerted by liquid is less than the weight, then object will sink in the liquid. If the buoyant force exerted equal to the weight of object, then object will float. the buoyant force exerted by liquid is more than the weight of object, then also object will rise and float. These were the three. It is in a structure word, in a structure sentence. If you wish, you can take the screenshot or you may write.
I actually wrote it down already, like almost similar.
Okay, then.
I'll take screenshot.
Yes.
Okay.
Actually, what you do against each of the mathematical expression, if you feel that what is the related with these, you write the statement and add the mathematical expression as well. Okay.
Yeah, I did like that, Elisa. I wrote B equal mg. The apparent force is more equal to the gravity, then it will float. Like that,
So
I wrote.
have you mentioned what is B or what is mg?
Gravity, I wrote.
B is the buoyant force and mg is the force due to gravity. Mention that as well.
Yes, sir.
Now we have some questions, I think. Answer this question. Why does boat float in water? Studying the all those concepts. What is the reason? Why does boat float in the water?
Because the boat is half immersed in the water, so it's equal to the weight of the water.
Displaced.
Displaced, yeah.
Okay. So your answer is quite right. Okay. So how the boat doesn't sink? Sometimes it sink. Okay. When it is overloaded, it sinks.
Sinks, yeah.
But when it is, this is the law of physics. Okay. If the buoyancy is equal or less than, equal and greater than the weight of boat, including the passenger and all, it won't, it will be safe. As it increases, it will
start to sink
down. Yes. So these are the question being asked in your books, or wherever it may be, for the examination as well, or for the general knowledge. Or general knowledge is not for the physics understanding. These are the question being asked. Now we have another point to see, the density of floating objects. We already discussed most of the thing, but it is in the structured way. When you discuss something, when you sit with the family members, you narrate all the stories. Okay?
Yeah, when you come, then you already know everything.
Everything. So it is like that you are re-listening all the stories.
Yeah, saying the same sentence again and again.
Yes. So that's how it's related. So actually, I did that earlier. When I got the concept, I thought it's good to just give all the idea just at one point, then we'll do later. So an object will float in a liquid if density or average density is less than and equal to the liquid. Okay, that's simple. So now we have 3-4 points. You already know it. The density of cork is less than that of water. The density, what is this cork? Is less than that of water. So cork float on the water. That's the, what is cork?
The bottle cap. Bottle
cap, right? So how its density is less than the density of water?
Because its weight is less than the water.
Actually, that is not the solid wood. Some process type of woods, right? That is basically made up of wood, right?
Yeah, it's made of wood.
Yeah, but it's not the solid wood. If solid wood will be, it will be sink down.
Okay.
So is the average density or something is density that it may be it like some porous thing. If you will see, it is not very hard. It's some porous thing. So because of that, the average density, maybe average density, because what is density? Mass per unit volume is less than that, the system, less than that of water.
Okay.
The density of wood is less than that of water, therefore would float on the water. There is density of wood. Wood means that I don't think that yeah, of course, if you will see that back in the village, all the woods are being ferry in the river.
Yeah.
Yeah, that's one of the transport mean. So density of ice is less than density of water, so it's float. We already discussed in a bit. That's one of the law of nature. If density of ice were more than of water, then it could have sink to the bottom of the what can I say? Bottom. So the living organs over there, herbs and herbs, they might have died under that. So this is the law of nature, how this world is being what can I say, shaped, that each and everything in the nature is unaffected by one another. There is coexistence. So in the glacier, you have seen in the basically in the Europe or somewhere the
thick ones are floating on water.
If it
half of it is in the water, so it's like immersed. Half of it is in the water. The rest of the top is floating.
Yes. So it looked like a heavy mountain, but still water is saying no, don't come inside that much. Other creature also over here, so let them stay in peace. So density of glass is less than density of mercury. That's one of the things. Density of glass, density of iron is less than that density of mercury. Therefore, nails of iron floats in mercury. Yeah.
Oh, iron is less than mercury. How? Because
density of iron is less than density of mercury.
So is mercury has higher density than water?
Yes.
Yeah, okay. Then I understood, yeah.
Okay, so now we have listing of some density. We already studied it in last class. What is density?
Yeah.
So now we have a listing of some densities. So we see that we have the reference point for the water. And we see that wood, ice, these all have less densities. And then glycerine, glass, aluminum, iron, mercury, and gold, they are more denser than water. Mercury is, this is water is 1000 and mercury is 13,000.
Okay.
So it is 13,600 thicker than water. This much times thicker than water.
Okay.
So you may take a screenshot. No need to write it down. Okay. Just keep in mind the density of water is 1000 kilogram meter cube. Just keep in mind. That's it. This is the standard information you have to keep in mind. The screen is short. Should I increase the size?
No, it's fine, sir. It's fine. So I took the screenshot.
Okay, that's good. What is this? What is
It's,
this?
it's the same thing, but putting the numbers in gram.
Gram centimeter cube. So we don't have to much worry about it.
Okay.
So we don't have. Now you have a question. An object of 50 gram has volume 20 centimeter cube. Calculate the density of object if the density of water is 1 gram centimeter cube. So this is change only. In meter, it was 1000. In gram, it is 1 gram per centimeter cube. So earlier it was kilogram meter per second. It is kilogram centimeter second. So it is only the change in what can I say, units.
Units, yeah.
Yeah. On basis of that, this question is being asked.
So to find density, we just have to divide 50 with 20.
What is the formula for density? Recall it.
Mass per unit volume.
Okay, density is mass per unit volume. So we have given the mass and volume as well.
Yeah. Okay.
Calculate it and compare with this quantity and answer these questions. Only one question, but somehow it's two questions, float or sink.
So I'm getting 2.5.
2.5, let me see if 50 gram divided by 20, so is 2.5. On this, what will be the dimension unit? Gram centimeter cube, right?
Yeah.
So now you have question to answer.
The object will float. No, it will sink. It will sink. Sir, it will sink.
Okay, it will sink for sure.
Yeah.
Because the density of water is only
1.0 gram per centimeter cube.
So its density is more than density of water, so surely it will sink. Clear?
Yeah.
Okay. So now we have to define, I think, the last definition. And this definition is relative density. How we will define the relative density? Relative density will be in relation with some other quantity. The other quantity is always given. When we talk relative velocity, a specific heat, these are the terms. There are some standard terms in physics. You will find that before that relative. It means that you may have, you will study about the refractive index. So there is also the ratio of two things, and there will be one a specific index that is in with respect to the speed of light. Okay. So here is the relative density, the density of substance divided by density of water. Here is the density of substance is 2.5 gram per centimeter cube, right? So in this case, the relative density of this relative density will be density of that substance 2.5 a gram centimeter cube divided by 1 gram centimeter cube. So this unit will be cancelled. So it will be in relative density 2.5, and the unit will be it will be unitless, right? So relative density is dimensionless. There will be no dimension. So if we will further try to make the mathematical statements of it, so just write the density of substance. What is density of substance?
Density of substance would be gram per centimeter cube. No, or just
Gram per
mass.
centimeter cube is the unit. Okay, gram per centimeter cube is the unit.
Will be
This is the mass. I'm writing in the capital M, mass of substance.
Or substance
by volume of substance. Volume of substance, right?
Yeah.
So again, we have to divide it with density of water. So I will write here mass of water divided by volume of water, right? That's good.
Why?
Cool.
No. Why are we doing mass of water divided by volume of water?
How it is defined? The relative density is defined at. We have to divide the density of substance with density of water.
Yeah. So the substance is water?
No, other than water.
Oh, okay.
We are defining in reference of water.
Okay.
Okay, so that's why it's relative. So mass of substance by volume of substance is density of substance, and density of water is mass of water divided by volume of water. So now we can cancel these two, right?
Yeah.
Volume of substance and volume of water means that the same amount of water will be displaced. That's why the volume of substance and volume of water is equal.
Okay.
Got the point?
Yes, sir.
So we will be leaving with mass of substance by mass of water. That's it reduces to now mass of substance divided by mass of water. Clear?
Yes, sir.
Okay. So further you have one question.
Relative distance. Okay. Sir?
Yeah.
For the 1.0 into 10 cube kilogram per meter cube, can I just write it as 10 cube kilogram meter per cube? Per meter cube? Because it's multiplying into 1, that's why I thought like.
Yeah, of course. Yeah. You don't need to write the dimension, kilogram meter cube. Okay.
Okay.
We finally add into the calculation. We already know what will be the final results.
Yeah.
So if you are confused, then you may take, if you don't sure that what will be the dimensionality, final dimensionality, then take. Otherwise, we just drop it and add into the final calculation.
Okay. So I'm confused. After I wrote 10.8 into 10 cube, then I always get confused what to do next.
See, what is relative density? We already see the formula. That relative density is, so I'm doing calculation for you. Okay. What is relative density? That is
Density of the substance by density of water.
So where should I write? I
You can
didn't.
erase. You can erase the mass, that one which you did, because I already wrote it so down.
Okay, so we may write over here. So the relative density of silver is 10.8. You know that?
Yeah.
10.8. Okay. So this side it will be relative density of silver.
Silver.
Density of
Silver by density of water.
By density of water is how much? This
10 kilogram per meter.
110. This is 10. What you were saying? If you don't know what will be the final
Yeah,
density,
I
just write it like that. Okay. Now what we have to do? We have to do the cross multiplication. That I'm not going to do it. You do the cross multiplication and fix the numbers.
I did I did was I took the 10 cube to the other side, so I made a density of silver is equal to 10.8 into 10 cube. That's how I did.
10.8 into 10 cube. Okay, so how you will write it? You will write it like it?
Yeah, I don't know how to. Then the next step I don't know how to do, like divide.
10.8 into 10
I
raised
thought
to the
to
3.
keep it like that.
This is kilogram meter cube. This is your density of silver. Density of silver. So if you want to,
I did 108 by 10 into 10 into 10 into 10.
Okay, so you did like that. 108
by 10.
And then 10 cube. You may have written like 10 into 10. That's it. That's cool. For 10 to 10. Yeah. Then, so yeah, go ahead.
Yeah. Then 10800. I don't
know. So 10,880,00.
But like then I think you keep the 110.8 into 10 cube like that.
This is also true. This is also true. But if you want little bit more scientific, if you want to sound little bit more scientific, so what you will do? This scientific in the scientific figure, what we do 10.8 into 10 to the power 3. I'm leaving the units. Okay. Yeah. Okay. So in scientific unit, you have seen that, for example, 9.8. Okay. 6.67 into 10 raised to the power something, 12 or something. 1.6 into 10 to the power minus 19 coulomb. Okay. What is the common in all these? You have seen that in the left side, in the left side from decimal, there is only one digit.
Yeah, only one.
Okay. So these are the scientific notation. So if you wanna sound more scientific, then what have to do? Let's see. Try to learn. Okay. If you will understand over here. What I will do, I am multiplying it with 10 and dividing it with 10. Right? There is no harm in the equation. We can do it.
Why is it another 10 next to the 10 cube? Why did we add another 10?
Just I have multiplied it by 10 and divided it by 10.
Okay.
Okay. So if we divide 1 over, sorry, 10 over 10. How it will be? It will be 1.
1. Yeah.
Okay. If we are dividing 10.8 by 10, what will be the outcome?
108. No, yeah, 108.
I want you do the mathematics and tell me.
No, sir, it's 108. It's 1.08.
1 point, right? So now if if we write it like 1.08, it will sound like it is bit scientific. So what I will do now, I will take these numbers together, okay, and these numbers together. So with these number, it is 1.08, and with left one number, it is 10 raised to the power 4. Clear?
Yeah.
So it is the scientific notation.
Okay.
So no need to write like this, okay, and neither like this. Always follow this notation.
Okay.
Now confusion is erased, I think.
Yeah, I understood.
Okay, so you understood the procedure as well?
Yes.
Okay, so I won't ask you much question because in your standard, this is too much.
Yeah.
So these are some relative densities of the object because we are calculating with respect to water. So water is taken as the unit amount, and then see the cork, wood, ice, and glycerine, gold, and all those things. Right?
Yeah.
Okay, so I think by this problem, we will be ending this chapter.
Okay.
Answer these questions now. My time to relax. Okay, I was talking and talking. Now it's your time.
No, I got all the answers. Sir? Sir, you're muted.
If you got the answer, then celebrate it.
Okay, I thought you're calling someone and I was distracting you.
No, if you got the answer, then celebrate it. And I will send you more questions.
Okay.
The assignment, okay?
Okay.
Okay, then.
Thank you, sir. Take care.
You're most welcome, you too. Okay, bye.